Good evening, one and all. Myself, MSP Durkarao, working as an assistant professor, Department of Computer Science and Engineering, Madanapalli Institute of Technology and Science, Madanapalli. Here I am going to discuss about heap data structure. We can also call it as binary heap. So, heap data structure. In this in this discussion, I'm going to discuss about the introduction related to heap data structure and how to construct a max heap from binary tree. So heap data structure is nothing but it is a binary tree that should be a complete binary tree that satisfies the heap property. It is also called it as a binary heap. Through that we can come to know that we can consider as it is a binary heap. The name itself it is also called it as a binary heap because it follows a binary tree concept. So in that case it should follows the complete binary tree. So here you should focus about the complete binary tree also. If whenever you are constructing the binary tree, in that mainly we are only focusing on full binary tree, strict binary tree and complete binary tree. So while constructing a binary heap, you should focus on or you should consider it is that binary tree should be a complete binary tree. So what is complete binary tree? A complete binary tree is nothing but it is a binary tree in which every level except possibly the last level is filled. So except the last level, see here this diagram, through this diagram you will understand. So this is the binary tree, it follows the insertion of nodes. So insertion of nodes followed from left to right. So here except the last level every node is should be filled. So this is a complete binary tree. This is an example for complete binary tree. So here the actual definition of complete binary tree. A binary tree is called a complete binary tree if all leaf nodes are at height h or h minus 1 and also without any missing number in the sequence. That means in binary tree we can calculate the height from based on the levels. So how many levels of that tree is having, how many level of nodes the tree is having, based on that levels we can consider as that height is equal to the levels. So here you can consider this is a first 0th level and first level and second level. So based on these levels the height of this tree is 2. So what they have mentioned the condition, if it is a complete binary tree means if all the leaf nodes are at height h or h minus 1. So height h in the sense height 2, so here leaf nodes are available and h minus 1 first level. So that means the level h minus 1 and h level only consisting of the leaf nodes, that tree should be a complete binary tree. So now this tree is a complete binary tree. Now so the next step is we can construct a max heap from binary tree, that to be a complete binary tree. So max heap and min heap. So heap data structure is nothing but it is a binary heap or it follows a binary tree concept. Through that binary tree concept we can construct a max heap or a min heap from binary tree. That is the process of heap data structure. So the main importance of heap data structures, by using heap data structures we can implement priority queue also. That is one more point. One more point you should remember it. So here heap property. So with how to construct a max heap or min heap from binary tree with the help of heap property. Heap property it plays a vital role to perform to construct a max heap or min heap from the binary tree. So based on the heap property only, it plays a vital role. With the help of heap property we can construct it. So for example, what is max heap and what is min heap? We all knows about binary tree. In binary tree we can insert elements based on the left to right. Every node based on the every node should consisting of two childs or 0 childs or 1 child. Based on that we can construct a binary tree from left to right. The insertion started from left to right. So like the way, so if every node, for example if you take binary tree consisting of left subtree and right subtree, if you consider every node, each and every node always greater than its childs, and the key of the root node is the largest among all the nodes available in that tree, that is called max heap. That means whatever it is the elements available in that binary tree, all the elements, that means each and every node is greater than their childs, left child and right child, and also the root node should be maximum when compared to all the leaf nodes. That is called maximum binary tree or a max heap. That is the minimum heap is opposite to the maximum max heap. That is, whatever it is the elements available in that tree, the root node having the small element when compared to the all leaf nodes. That means each and every node is smaller than their childs. That is called min heap. Now here we are going to construct a max heap. Before that, we can see the max heap and min heap example. See here, this is the max heap. This is a binary tree. That too, this is a max heap. So with the help of heapify function, we can convert binary tree into the max heap. See here, this is the 12, and 12 consisting of two childs. One is 10 and another one is 9. Both 10 and 9 less than 12. And again 10 consisting of 5 and 6 as childs. So both childs lesser than 10. And 9 consisting of only one child. So this 1 is less than 10, 9. So that's why we can call it as this is a max heap. See, every node is a maximum when compared to the childs, and that to root node. The root node should be maximum when compared to all the nodes. Similar to the minimum heap, this is opposite to the max heap. See, the root node is minimum to the and all the nodes available in the tree. So this is minimum heap and this is the max heap. Now, how to construct? So these are the still we only discussed about the definitions, binary tree and complete binary tree, min heap and max heap. Now actual process is going on. How to convert a binary tree into the max heap? We have already discussed with the help of heapify function, heapify property. We can convert a binary tree into the max heap and min heap. So now, coming to the heap operation. What is this heap operation? Heapify is the process of creating a heap data structure from a binary tree. It is used to create a min heap or a max heap. That we have already discussed. So see, for that we are following some algorithm. So through algorithm we will discuss it. First, let the input array. We can take input array based on the index, the array index based on the elements. Sorry. So array index started from, you all knows array index started from 0 to n minus 1. So now we are taking these elements. This tree is consisting of six elements. That means 0 to n minus 1. 0 to n minus 1. Like the way we have to take the input array first. Input array according to binary tree. According to binary tree positions, we have to take the input array, and next create a complete binary tree from the array. Create a complete binary tree from the array. So based on this array we are creating, or else you can take from we used to take array, we used to construct a binary tree based on the elements only. So now we are taking the input elements. So based on that elements we can construct a complete binary tree. After that, actual process will start. We can apply the heapify functions to make the max heap. Now this is a binary tree, not minimum heap, not maximum heap. Now we can convert from this binary tree to the maximum heap. So for that we can apply the heapify function. So what is the heapify function? The heapify formula is nothing but it is n by 2 minus 1. This is the heapify condition. N by 2, n value here 0 to n minus 1, 5 variables. That means n 0 to n for n minus 1 elements we have inserted. That means n equal to 6 elements there in this binary tree. So 6 elements. So n value equal to 6. 6 by 2 minus 1, that is 6 by 2, 3 minus 2, 3 by 2, sorry 3, and 6 by 2, 3 minus 1, that is the 6 by 2, 3 minus 1, that is 2. That means you can start comparison from the index 2. The heapify function, through that heapify function one value it will come through, from that index only we can start the comparison. Because if you start from here, no need, no use, because this node is not consisting of any elements. So based on this property, this formula, we will get the exact location where we can start the comparison, where we can start comparison to make a maximum heap. So now we can start here. that too we are converting from binary to max heap. We should start from the right side. So index 2, based on this formula, our now our value, our index came after heapifying. So we can start from the 2. We can start from the 2. Now set this 2 as a largest element. According to the algorithm, we can assume like this is the largest element. Now you can according to the fifth statement, the index of left child is given by 2a plus 1 and the right child is given by 2a plus 2. The index is 2. You can now I we are current element I as largest element. We set I as a largest element. So I value 2. For that, 2 into 2 plus 2, that is 4 plus 2, 6 is the right child, and 4 plus 1, 5 is the left child. So according to the condition, this is true. Now we can start the comparison. So if left child is greater than current element, now current element is this, we can compare current element with their children's. So this current element is only having one child, that is left child. If left child is greater than current element, we can swap with the current element. We can swap left child with current element. At the same time, if current element is having right child also, you can compare with right child also. Which one is, after comparison left and right, which element is greater than the current element, that element can be the root node. Like the way we can convert binary tree into the max heap. So this process we can now we can swap the here 5 is greater than 2, so we can swap 5 with 2. So swap largest with current element. So now 5 is the root and 2 is the 2 is the least element. So we perform the swapping. So repeat this step until total tree is heapified. This is the way we can convert from binary tree to the max heap. These are the sample examples of max heap. See here, scenario 1 is already heapified. Coming to the scenario 2, in that 7 is the large when compared to 2. When compared to 2, 7 is the large. So for that case, we can swap with 7 into 2 to make a max heap. Example. This is the example. So in this example, both subtree of left subtree and right subtree already heapified. That means max heaps only. So 10 when 10 is having two childs, 5 and 6. 5 and 6 is less than 10, and 9 is having 1 is less than 9. Now we can move to the root node. So next step, root node. From this tree we can move to the root node. So root node is having two childs, one is left and right. In that case, we can compare with left child and right child. Which element is the greater than the current element? That element should be the root. So here 10 is the greatest. 10 is maximum when compared to current element. So we can swap with the current element with the maximum element. So after performing every iteration, we should compare every iteration the tree, check whether the tree is max heap or min heap. We have to check whether the tree is max heap or min heap. So here after swapping, tree is not satisfied. So for that, again we can compare with the childrens of this node. So here 6 is the maximum element. So we can swap 6 with the 2. Then this is the final max heap. So actual algorithm. So how to perform? So here in that we have seen already in that algorithm, based on the heapify condition, we can set I as a largest. We can based on the heapify, whatever it is the index came, that index element we can set as a largest element. Then we can compare with the left child and right child. If left child is greater than current element, then we can make it as a left child as a largest, and right child is greater than current element, then make it right child as a largest. This process will continue until total tree will be heapified. So now build a max heap. Now we can build a max heap. This is the current elements. The array consisting of 6 elements, index 0 to 5, that means n equal to 6. And we can calculate the I value. I equal to 6 by 2 minus 1. So 6 by 2 minus 1, this is heapify function, n by 2 minus 1, so that is 2. That means the loop runs from second index to 0 index. Based on this array, we can construct the binary tree. So binary tree is like this: 1, 12, 9, 5, 6, 10. So according to the heapify function, we should start from the second index, then first index, then 0th index. So now second index, compare with their childs. 10 is max, 10 is larger than current element, so we can perform the swapping. So after swapping, 9 and 10, after swapping, 10 be the root and 9 be the child. So according to the like the way we can change in array also. So after that, next the loop started from 2 to 1. So this side already heapified, then we can move to next index, that is 1. So in one index already heapified, one index, that means this side left subtree already heapified, then we can move to the next index, that is 0th position. So now 0th position. So if this is the current element, you can compare with the left and right child, which one is the largest element, that should be the root. That means we can swap with that current element. So now 1 is the root element, this is the minimum element when compared to the 12 and 10. In that case 12 is the maximum, so we can swap with 1 with 12, 1 with 12. Then after that also this tree is not satisfied, because 5 and 6 greater than 1. Then again we can perform, again we can compare with the childs of that current element. So 6 is the largest element when compared to current element, so we can swap with 6 and 1, and finally we will get the final max heap. You can here you can observe, here 12 is maximum when compared to 6 and 10, and coming to the left subtree, 6 is the larger than 5 and 1, and coming to the right subtree, 10 is larger than 9. This is the final max heap. So I hope you all understand, this is the way we can construct, we can convert binary tree into the max heap, or we can construct binary tree to the from binary tree we can construct max heap or min heap by using heapify. Like the way we can also construct minimum heap also. So I hope you all understand. Thank you very much.